Hi everyone, this is a video about how to calculate the area of certain figures. First of all, area is a two-dimensional type measurement. We've talked about length measures. So area, like in a rectangle here, is the amount of space that is covered by that shape. So we're talking about this whole space that is covered. And there are some formulas that we kind of need to know. One is for a rectangle, and the area of a rectangle is your length times your width, so one dimension times the other dimension. And you do want to be a little bit careful to make sure that those dimensions are in the same units. So if one is in inches and the other is in feet, you want to make sure that they match up. The other shape we will be dealing with is a circle. And in a circle, I want to remind you the radius is from that middle to the outside. And the area of a circle is pi times your radius squared. Now it's just the radius being squared. You don't take pi times r and then square that result. You'll take your radius and square it and then multiply that by pi. A triangle, and I'm going to draw a couple triangles. So a triangle, first of all, in a triangle with the height, excuse me, is the perpendicular line, that imaginary line that's going from the highest point to the base, or to where that base is located. And the area of a triangle is 1/2 your base times your height. So here's your height and here's your base. So the base would be that whole distance from here to here. Now if I had a triangle that was kind of weird shaped, okay, the base here is still the base of that triangle. Now the height we can't really draw in here, so I would drop that perpendicular straight down, and I kind of put some dotted lines here. So the height would be whatever that piece is in there. The base does not change. The base remains consistent to the triangle itself. We don't add on this extra part. Otherwise, we'd be finding the area of the triangle outlined with those dotted lines as well. So you do have to be a little bit careful. One thing to note, though, is you could rearrange this triangle. So I'm just going to turn it. Magic of the paper is I could turn it and I could put my height here, and then this would be the base. So you can reorient those shapes whatever way is easier. Sometimes in a triangle, though, depending on where it's located in the real world, it may be a little bit more difficult to calculate. So let's do a problem. And the problem I'm going to do is I'm going to jump into something a little bit more difficult. And let's say I have a wall. Okay, so this is a wall of a house, because you're going to be learning in a section down the road of how to find a heat load for a room. And the heat load is dependent on the area surface of the wall between the room and the outside air. So let's say this is an outside wall, and let's say that this is 18 feet 3.5 inches. Some weird shape, and we have a 7 feet 6 inch high wall. But on this wall we have a circular window, so this will kind of take place of all of our pieces. I'm going to draw kind of big, and it happens to be 3 feet across. Okay, and I want to find the area of just the wall part. And so what I mean by that is not including the window. So basically I'm going to take this rectangle and throw out the window. So I'll kind of write that down. So it's going to be the rectangle minus the window. Hopefully you guys can see that, picture that in the picture here. So the whole rectangle, and then we'll get rid of the window. So the area of the rectangle, first of all, is your length times your width. So we're going to write this in terms of just feet alone. So I'm going to remind us how to do that. So we're going to take that 3.5 inches, turn my calculator on, 3.5 is 3.5, and we're going to divide that by the 12 inches per foot. And that comes out to be 291,666. So I'm just going to write this as 18.29, and that's going to be now in feet. I could add more decimals if I wanted to. So if I wanted to do 291,666, I could. I'm going to do the same here for 7 feet 6 inches. Now most of us know that 6 inches is half a foot. So this becomes 7.5 feet. So I'm going to take these two things and multiply them together. 8.29 times my 7.6, 7.5. Ooh, almost made a real major error there. 18.29 and multiply by 7.5. And I come up with 137.175. Okay, now we need to get rid of the window. So the area of a window is pi times our radius squared. So we need the radius of this circle. Now this is a 3-foot diameter, and that might be easier to measure because going from one side to the other is easier than trying to figure out exactly where that middle is. So half of 3 is 1.5, and I do want to do it in terms of feet because these I did in terms of feet. So this is going to be 1.5, and I need to square that. So on my calculator, clear this, I'm going to do this 1.5 squared, so 1.5, and I have a little squared button right here, which will put a little 2. You'll see the little 2 pop up there. So that's my 1.5 squared. And then I'm going to multiply that by my pi. And I like to use my pi button, which is also located right there. So times my pi, and we'll get that to be 7.07. Well, actually, why don't I go 69? Since I have 3 decimals here, I'll go 3 decimals on this one. So 7 point, and that's where it is, right? 7.69, 069. So now I'm going to subtract those two, 137.175 minus the 7.069, and I come up with 130.106. And again, depending on where you want to round these and how accurate you're going to be will determine how many decimals you want to use. Some things to note now is the units that this is measured in. To cover this floor, we need to kind of fill it full of little squares. So our units are going to be square feet. Or we could write this as feet with a little 2 on it. So there's our 2 ways we could write it. We could abbreviate this too, SQFT if you wanted to. So lots of different ways to write square feet. Hopefully that's helping. I'm going to do one more. Well, actually, I'll do one more. Let's find the area of this shape. Okay, and I'm going to have, it's supposed to be a rectangle. So, and I'm going to put a triangle on top of it. So we're finding this whole area. And let's say that I know that the total height of this is 20 feet 8¼ inches. I know that this here is 10 feet 3 inches. And let's say I know that this from here to here is, and it's probably not drawn to scale, but we'll make it 8 feet even. Okay, and we're going to find the area of the entire shape. In order to do this, we're going to find the area of my rectangle. So the area of my rectangle, and I'm going to add the area of my triangle. My technical notation here. The area of a rectangle is your length times your width. The area of a triangle is 1/2 your base times your height. So we need to get all those pieces. Alright, so starting with my rectangle, that's this bottom part. I'm going to be taking that 10 feet 3 inches, and I'm going to take that 3 inches and turn it into part of a foot. So 3 divided by the 12 gives me 0.25. So 10.25 times my 8. Okay. Then I'm going to have my 1/2, my base. Now if I'm looking at the triangle, this base is the same as this if this was a true rectangle, which it was supposed to be. So 8. And I need the height of my triangle. Now the height of the triangle is not this full 20 feet. It's going to be the 20 minus that part. So here's the height of the triangle. So I need to take my 20 feet 8 1/4 and subtract off my 10 feet 3, which gives me a 10 feet 5 1/4. So I'm going to take 5 1/4, so 5.25, divide that by 12, and that gives me 10.4375, and that's going to go in here. And now I just need to do the arithmetic. So 10.25 times 8, that's 82. And then I'm going to do 1/2, which is 0.5, times my 8, times my 10.4375, which is 41.75. And now adding those two together is 123.75. And again, we did everything in feet, so this would be square feet. And there you have it. I've done an example of rectangles, triangles, and circles. So hopefully this helps you with your homework and a little bit about how area is calculated.